Welcome to the deep dive. We often talk about the importance of getting the right answer, but today we're going to dive into something even deeper when it comes to learning math. Like how do you actually get to those right answers? How many different ways can you think about a problem?
Yeah,
That's what we're calling mathematical flexibility.
absolutely. And we've got this really interesting systematic review of research. It dives into how experts are understanding and explaining and even assessing this key ability.
Okay, so this is more than just like knowing your times tables or being able to solve for x,
It
right?
really is. And one thing that's really cool about this review is that it kind of brings together all these different perspectives that researchers have on it. Some researchers are really focused on what does it actually mean to be flexible when you're solving a math problem? And then others are really looking at, well, how do we actually measure that? How do we know if someone's being flexible or not? And then a big chunk of the research also looks at what are the things that help someone become more flexible in math? Or conversely, what are some of the things that might create roadblocks?
Hmm.
So, in this deep dive, our goal is really to kind of synthesize all of that for you. Give you a nice, well rounded understanding of what mathematical flexibility is, why it's so important. We'll be looking at how it's defined, how we measure it, what influences it, and even some effective ways that we can actually help learners become more
I
flexible.
love it.
Yeah, and we'll even touch on this cool three-dimensional model that can
Hmm.
help us really kind of bring it all together and see it in a more comprehensive way.
I'm intrigued. I'm intrigued.
Yeah.
Okay, so let's start unpacking this then. When we talk about mathematical flexibility, what are we actually talking about? What does that really mean?
Yeah. So, at its core, I think we can say that mathematical flexibility is really the capacity to solve a given math problem in more than one way. But, and this is the important part, it's not just about having a list of, procedures or formulas in your head. It's also about being able to kind of choose which one is most appropriate for the problem at hand, and maybe even being able to modify or adapt strategies as you're working.
So it's not just about having options, but about intelligently choosing between those options.
Yes, yeah, exactly.
I like it.
And, one of the things that the review kind of brings up that I think is an interesting distinction is this idea of flexibility versus adaptivity.
Oh, okay.
So sometimes you see these terms used a little bit differently in the research, and some researchers really emphasize that flexibility is about switching between methods.
Okay.
So, for example, if I give you a problem and you solve it one way, and then I say, okay, can you solve it a completely different way? And you can do that without, too much difficulty.
Yeah.
That would be showing flexibility. But then adaptivity is sometimes used to emphasize the selection of the most suitable strategy right from the get-go. So, looking at a problem and saying, okay, out of all the tools in my toolbox, which is the one that's going to be most efficient or the most helpful for solving this particular problem?
Got it. So I'm hearing flexibility is maybe more about breadth, like how many different tools you
Yeah.
have. Adaptivity is more about being skillful about choosing the best one for the job.
Yeah, that's a really nice way to put it.
I try.
Yeah.
So are they always seen as separate things or do they sort of blend together?
Yeah, that's a really good question. And I think, the review does point out that they're not always treated as totally separate concepts.
Yeah.
So you'll see researchers who use them almost interchangeably because, the underlying goal in both of them is really about being effective and solving the problem appropriately.
Hmm.
But I think it is helpful to sort of see that there is this nuance, where is the emphasis being placed? And, a classic example might be think about multiplying 15 by 12.
Okay.
Flexibility might be, you can solve it by doing 10 times 12 and then 5 times 12 and adding those together.
Hmm.
Or, you could do 15 times 10 plus 15 times 2.
Right, right.
So that would be flexibility. But adaptivity might be, if I change the problem slightly and I say, okay, now it's 15 times 18, maybe you recognize that the best way to do that is to break down the 18 into 20 minus 2
Oh, okay.
and
Yeah.
use the distributive property.
Right.
Because
Yeah.
that's going to be more efficient than, doing all those repeated additions.
Right. So interesting. I feel like as you're talking, I'm realizing all these little ways that this shows up,
Yeah.
even in really simple problems.
Yeah, absolutely.
Now, I know the review also uses these terms, practical flexibility and potential flexibility.
Yes.
What do those mean?
Yeah, so those are really interesting too, and they kind of help us to think about, okay, well, how do we actually measure this? How do we know if someone is being flexible.
Mm-hmm.
So practical flexibility is sometimes also called spontaneous flexibility, and it's really just like the flexibility that a person actually demonstrates when they're solving a problem.
Okay.
So like what strategies do they just like spontaneously come up with and use?
Mm-hmm.
Whereas potential flexibility is more about like the range of strategies that they know and could employ.
Okay.
So it's like what's their potential for being flexible, even
Ah.
if they're not necessarily showing it in that particular moment.
Interesting. So one's what they do and one's what they could do.
Yeah, exactly.
I like it. And I think I remember reading in the review, they kind of break down that potential flexibility even further.
They do. So they talk about potential flexibility as being kind of a combination of what they call procedural flexibility, which is just, knowing multiple procedures.
Hmm.
And then this other thing called potential flexibility BC.
Potential flexibility DC. That sounds fancy.
I know, it's a bit of a mouthful.
So what does that mean?
So think about like procedural flexibility as knowing how to do different algorithms.
Okay.
Right? Like you know how to do long division, you know how to do, multiplication in different ways.
Mm-hmm.
But potential flexibility BC gets at like that conceptual understanding. So
Yeah.
it's like, do you understand why those algorithms work and how they connect to like the bigger mathematical ideas?
Got it. Okay. So it's like not just knowing the steps, but knowing the why behind the steps.
Yeah, exactly.
I'm with you.
So, you might be really good at following a procedure, but if you don't understand why it works, it's going to be harder for you to be flexible and adapt it to a new situation. So that potential flexibility BC is really kind of tapping into that deeper level of understanding.
Okay. I'm totally with you. So we've talked about like what it is, but now I'm wondering, like, why should we care about this? Like, why is mathematical flexibility so important?
Yeah, that's the big question, right? I mean, it sounds nice, but like, why does it matter?
Right.
And, I think one of the things that you touched on at the beginning was this idea of like being well-informed in mathematics, right? So if you're someone who has mathematical flexibility, it suggests that you have a much deeper and more interconnected understanding of those mathematical concepts.
Okay.
So it's not just about like rote memorization or applying rules blindly. It's about really understanding why things work and how different ideas relate to each other.
Right. And I'm imagining if you only know one way to solve a problem, your understanding of that underlying math might be pretty limited.
Yeah, exactly.
But if you can see it from multiple angles, you've probably got a much stronger grasp of the concept.
Absolutely. And that deeper understanding then leads to like really important benefits when it comes to problem solving.
Okay. Like what?
So first of all, it can make you more efficient,
Okay.
right? Because you can choose the most direct route to the solution. You're not like stuck doing something in a long roundabout way if you can see a quicker way to get there.
Right.
It can also make you less prone to errors.
Okay. That's always good.
Yeah. Because if you hit a roadblock with one method, you've got like these alternative pathways that you can explore.
Right. You're not just stuck.
Exactly. And that ability to kind of like pivot and try something else is really crucial in math.
Yeah, that makes a lot of sense. It's like, I don't know, it's like you're trying to get somewhere and there's a roadblock.
Mm-hmm.
And if you only know one way to get there, you're just out of luck.
Yeah,
But if you've got like a map with multiple routes, you can find a way around it.
exactly.
Okay, so it makes you a more versatile, adaptable, and resilient problem solver.
Yeah, I think that's a great way to summarize it.
Okay, I'm sold. So we've got a good sense of what this is, why it matters.
Yeah.
How do researchers actually go about like studying this? How do you measure mathematical flexibility?
Yeah, so that's a really important question. And the review kind of highlights a few different ways that researchers have tackled this.
Okay.
One of the most common ways is to look at the number of different strategies that a person can come up with for a single problem.
Okay.
So, if you give someone a problem and they can only think of one way to solve it versus someone who can come up with like 3 different ways to solve it, you might say that the person who can come up with 3 different ways is probably showing more flexibility.
Right. More tools in the toolbox. Okay, that makes sense.
Yeah, so that's kind of a straightforward one, but
Yeah.
it goes beyond just the number of strategies.
Oh, okay.
What else? Another really important thing that researchers look at is, can the person actually switch between those strategies? So it's one thing to know that different strategies exist, but can you actually like in the moment, move from one to another.
Mm-hmm.
And sometimes researchers will do this by like observing students as they're solving problems, or they might even specifically ask them to like solve the same problem in multiple different ways
Okay.
and see like how easily can they do that? Are they kind of fixated on their first method, or can they, really adapt and switch to a different one if they need to?
Interesting. So it's not just about knowing in the abstract, but being able to actually use it.
Yeah, exactly.
Yeah.
And then another really important thing is, are they choosing strategies that are appropriate for the problem?
Oh, right. Because sometimes one way might technically work, but it might be like way more complicated or take way longer.
Exactly, exactly. And so, a student who is really mathematically flexible, they're not just coming up with a bunch of different solutions. They're also able to kind of like look at the problem and say, okay, what's the build tool for this job?
Right.
What's the most efficient way to solve this particular problem?
Okay. So appropriateness is another factor.
Yes.
Got it.
And then finally, related to that is this idea of efficiency.
Mm-hmm.
So how quickly and with how little effort can the person solve the problem using that particular strategy?
Right. So it's not just about getting the right answer. It's about getting there in a smart way.
Exactly.
Exactly.
Okay, so we've got a pretty good picture now of how they actually study this.
Mm-hmm.
So let's talk about what factors actually influence whether or not someone develops this. Like what makes someone more likely to be mathematically flexible?
Yeah. And the review actually kind of dives into a few key factors that seem to be really important.
Okay.
As you might expect, knowledge is really foundational.
Okay.
So having a strong foundation in the mathematical concepts and procedures that you're working with, that's kind of a prerequisite. You can't really be flexible with strategies that you don't know or understand deeply. Right, like you need the building blocks before you can start rearranging them in different ways.
Exactly. Exactly. But it's not just about the knowledge itself, it's also about how that knowledge is acquired.
Oh, okay.
So the way mathematics is taught can have a really big impact.
Makes sense.
If students are only ever shown one way to solve a particular type of problem, they're not going to have much opportunity to develop that flexibility.
Right.
But if instruction really encourages them to explore different strategies, compare them, talk about the pros and cons of each method, that can really foster flexibility.
I see. So teachers who are always saying, okay, now let's think about another way we could have solved that, they're really helping their students.
Absolutely.
Okay, so it's all about how it's taught.
Yeah. And the review actually points out that these activities that involve comparison of different solution methods, those are really beneficial.
Okay, interesting.
Yeah,
So it's not just about the teacher showing them the different ways. It's about actually having the students engage in that comparison.
exactly. And then we also have to think about some cognitive factors that come into play.
Okay.
So, things like working memory, which is your ability to kind of like hold information in your mind and manipulate it. That's really important for flexibility.
That makes sense.
And also inhibitory control.
Inhibitory control, what's that?
So inhibitory control is basically your ability to resist sticking with like a familiar strategy, even if it's not the best one.
Oh, interesting. Okay. So it's like being able to let go of that first idea, even if it feels comfortable.
Yeah, exactly. If you've got good inhibitory control, you're better able to kind of like overcome that mental set of like, this is the way I always solve this problem, and kind of open up your mind to other possibilities.
Right. So if you're like really stuck in your ways, it's going to be harder to be flexible.
Yeah, absolutely.
Okay. So we've got knowledge, we've got how it's taught, we've got these cognitive factors. Anything else?
Yeah, the review also mentions briefly some affective factors,
that's
like
okay.
things like math anxiety.
Hmm.
So if someone is feeling really anxious about math, it can sometimes be a barrier to flexibility.
Right. Because if you're already stressed out, you're probably not going to want to try something new and unfamiliar.
Yeah, you're going to want to stick with what you know, even if it's not the best strategy.
Makes sense. So we've talked about what mathematical flexibility is, why it matters, how it's studied, what influences it. Big question now. How do we actually help learners develop this?
Yeah, so that's where the research gets really exciting, because it's one thing to just describe it, but it's another thing to say, okay, well, how do we actually like make this happen in classrooms?
Right.
And the review looks at a bunch of different interventions that have actually been shown to be effective.
Okay, so like things that teachers can actually do.
Exactly.
Okay.
And one of the big takeaways is this idea of comparing different solution methods.
Okay, yeah, we were talking about that before.
Yeah, so we already kind of touched on that, but it's really important when students are exposed to multiple ways of solving the same problem and they get to like discuss, why might one method be better than another in a certain situation, it really deepens their understanding.
Right. So just seeing that there are different ways to do things,
Yeah.
that's a big part of it.
Yeah, and actually like analyzing those different ways and thinking about like, okay, well, when would I use this one? When would I use this one? That's really powerful.
Okay, so comparing is a key strategy.
Yeah. And then another one that's been shown to be effective is actually having students generate multiple solutions on their own.
Oh, okay. So not just showing them the different ways, but
Yeah.
actually having them come up with them themselves.
Exactly.
Interesting.
Because that really forces them to think beyond like the most obvious or familiar method.
Right.
So it's more active.
Okay, so encouraging that generation of multiple solutions.
Yeah. And then another thing is being really intentional about the types of tasks that you're giving students.
Oh.
So if you're always giving them problems that only have one right way to solve them, they're not going to have a lot of opportunities to practice flexibility.
Right.
But if you give them tasks that naturally lend themselves to multiple approaches, then they're going to have to think more flexibly.
Okay, so choosing the right types of problems.
Yeah, exactly. Like moving away from just those like rote exercises and giving them problems that are more open-ended.
Right, more like real-world problems where there's not just one set way to do it.
Exactly.
Okay, so we've got comparing solutions, we've got generating solutions, and we've got choosing the right types of problems.
Yeah. And, when students engage in those kinds of activities, it really helps them to develop that flexibility over time.
Okay, this has been really interesting. I know there was one more thing from the review I wanted to make sure we talked about, and that was that three-dimensional model of mathematical flexibility.
Yes.
You mentioned it at the beginning.
I did, yeah.
It seems like a really good way to kind of bring all this together.
I think so.
Yeah.
It's a really nice framework for getting a more complete picture of it.
Okay, so tell me about it. What are the three dimensions?
Okay, so the first dimension is what they call analytic units.
Analytic units. Okay.
And this is basically referring to, like, what is the flexibility being applied to?
Okay.
So, for example, are we talking about flexibility with different solution strategies?
Sure.
Like, can you solve a problem in multiple ways? Or are we talking about flexibility with the underlying mathematical concepts?
Oh, okay.
So it's like, do you understand the concept in a way that allows you to be flexible with it?
Got it. So it's not just about, like, having different ways to calculate, but also about being flexible with the ideas themselves.
Exactly. And then, sometimes it's about flexibility with representations.
Okay.
So can you like move between, a numerical equation and a visual diagram?
Right.
Or a word problem and, a more symbolic representation of it.
Right. So lots of different ways to be flexible.
Yeah. And then the second dimension is what they call manifestation forms.
Okay. Manifestation forms.
So this is about how that flexibility is actually like shown.
Okay.
What does it look like in practice? So, can the learner generate those multiple different solutions?
Yeah.
Do they choose to use the most efficient strategy?
Mm-hmm.
Can they adapt a familiar strategy to like a new problem that's slightly different?
Okay, so those are all, like, signs that someone's being flexible.
Yeah, exactly. It's
Yeah.
like those are the things we can actually observe. And then the third dimension is the evaluation criteria.
Okay. So how do we actually judge how good that flexibility is?
Yeah, exactly. So are the strategies that they're coming up with, are they actually novel?
Okay.
Or are they just like slight variations of the same thing?
Mhm.
Are they choosing strategies that are efficient?
Yep.
Are they appropriate for the problem?
Right.
And, ultimately, are they leading to accurate solutions?
Okay. So the model's looking at what you're being flexible with, how that flexibility is shown, and how we judge how good it is.
Exactly.
Okay. This is a really helpful model. I like this.
Yeah, and I think it really like highlights the fact that flexibility is not just this one thing.
Right.
It's really like a combination of all of these different aspects.
Well, this has been a really fascinating deep dive. We've covered so much ground.
We have.
We've talked about the definition of mathematical flexibility, why it's so important, how researchers are studying it, the things that influence whether someone develops it, even some practical ways that we can help learners become more flexible. And then, of course, this really cool three-dimensional model
Yeah.
to tie it all together.
It's a lot to think about.
It is. But I think the big takeaway here is that it's not just about having a lot of tools in your toolbox.
Right.
It's about knowing when and how to use those tools effectively.
Excellent.
It's about, having that understanding and that adaptability.
So I guess my question for you, the listener, is think about a time when you've been stuck on a problem, maybe not even a math problem.
Mm-hmm.
Did you consider different ways to approach it?
Mm-hmm.
What might have happened if you had really tried to like brainstorm a bunch of different solutions?
Yeah.
How might that change the way you approach things, not just in math, but, in life in general?
That's a great question.
Yeah, food for thought.
It is.
Well, thanks for joining us for this deep dive. It's been really fun.
Yeah, thanks for having me.
And we'll see you next time.